Alright, I'm going to go over the mCΔT practice worksheet. Before I get started, I want to introduce sort of the problem-solving method we'll be using for this sheet. So what we have here is an algebra circle that relates that equation Q equals mCΔT, and if you haven't used algebra circles before, the way that it works is that you cover up whatever variable you want to find, and it gives you the equation for that variable. So for instance, if we cover up here the Q, okay, we find that Q equals mCΔT because MC and delta T are all in line. If you cover up the M, you see here that M is going to equal Q over C delta T because Q is on top of the other two. Cover up C here, you get C equals Q over M delta T. So that's helpful in this process because we're going to be using a lot of different types of this equation or a lot of different rearrangements of this equation, and if you know how to use the algebra circle, that will definitely help you. So, going on to the first problem here, it says a 15.75 gram piece of an unknown metal absorbs 1086.75 joules of heat energy, and its temperature changes from 25 degrees Celsius to 175 degrees Celsius. Calculate the specific heat capacity of the metal. So in this one, first we have to identify what variable we're looking for. It says we're looking for the specific heat capacity, so that's C. If you go back to your algebra circle, you'll see that C equals Q over M delta T. So in this problem, we just need to put in the values for those different variables. Q is heat. So Q, looking up here, we're looking for something that's measured in joules. I see 1086.75 joules up there. All right, divided by the mass times the change in temperature. Okay, here the mass is given as 15.75. And the change in temperature, it went from 25 degrees Celsius to 175 degrees Celsius. But keep in mind here that we know this to the ones place. So when we write this, to keep the sig figs right, it's going to be 150 point for the sig figs. Okay, then you throw that into your calculator. We have a division problem here. Rule is that you go with the least number of sig figs. We have 6 on top, 4 for 15.75, and 3 for 150. So we should have 3 sig figs in our answer. So I get 0.460 joules per gram degree Celsius on that problem. Okay. Just curious, everything here, every substance has its own unique specific heat capacity. So if you look at the table of heat capacities that you've been given, you'll see that 0.460 is relatively close to what iron is. So this mystery metal is probably iron. Okay, going on to problem number 2 here. This one is asking for how many joules or how much heat. So the variable we're looking for is Q. Looking at the algebra circle, you see Q equals mC delta T. Mass in this case is 10.0 grams. The heat capacity here, it's aluminum, so you have to look it up on the table. It's 0.897. All right. And then the change in temperature here, it goes from 22 to 55, so that's an increase of 33. We multiply all these together. We have 3 sig figs times 3 sig figs times 2 sig figs, so our answer should have 2 sig figs. You put it in your calculator and you see that it is actually one of those ones that is kind of hard to make into a 2 sig fig problem because it's 300 is what it rounds to, and if we put a decimal place at the end, that would be 3 sig figs because both those zeros are trailing zeros with a decimal point. But if we have no decimal, then we see that it has 1 sig fig. So the way that you solve this is you put a bar above the top for the digits that are significant, and that gives it 3 sig figs. And then because it's energy, it has units of joules. Okay, going on to problem number 3, it says calculate the amount of joules needed to raise a 25.0 gram sample of water from 25 degrees Celsius to 75 degrees Celsius. So again, this one is looking for Q. The mass they've given us is 25.0. Because it's water, you can look on the table and see that water has a specific heat capacity of 4.184. The change in temperature from 25.0 to 75.0 is 50.0. All right. You go through, you multiply those together. Our answer should have 3 sig figs. So what I get from that is 5,230 joules. 3b is a very similar problem. It's just with grain alcohol instead of with water, so it sets up exactly the same way. Q equals mCΔT, which equals, in this case, 25.0 grams. Okay, now we have to look up C. For grain ethanol, it's 2.438. Then you multiply by the change in temperature, again 50.0. And you get, if you round to the right number of sig figs, 3,050 joules. So looking here, we can see that this is a different number than what it had said before. It says explain why there's a difference in heat required for A and B. Well, simply put, the reason there is that water and grain alcohol have different specific heats, so it requires a different amount of energy to raise the temperature of these substances by 1 degree Celsius. And so because water has a higher specific heat than grain alcohol does, it's going to require more heat to raise it that 50 degrees than what it would take for the grain alcohol. Question number 4 here, it says, what is the final temperature of a 50.0 gram piece of gold that absorbs 5,275 joules of heat if the initial temperature of the gold is 20.0 degrees Celsius? So in this one, first of all, you have to identify from the Q equals mc delta T equation, what we're solving for is delta T. So the change in temperature equals Q over mc, which equals 5,275 joules divided by 50.0 grams. And the C here we have to look up for gold is 0.129. You go through and you multiply those, and you get 818 degrees Celsius. Okay, so something to keep in mind is this is not our final answer, because this question asked us what the initial temperature of, what the final temperature of the gold was, given that the initial temperature was 20 degrees Celsius. And so you have to think back to what the definition of delta T is. Delta T is equal to the final temperature minus the initial temperature. Okay, so in this case, we have that the change in temperature is 818 degrees Celsius. All right, the final temperature is what we're looking for, so that's going to stay a variable. And the initial temperature is given to us as 20. So if we add 20 degrees to both sides, we end up seeing that the final temperature in this case equals 838 degrees Celsius. All right, going on to problem number 5. This one asks us to figure out the specific heat for a metal. It says it's unknown again. So specific heat is C. C equals Q over m delta T from our algebra circle. Which equals, in this case, we know the heat is 455 joules. The mass is given us 25.0 grams. And then for delta T, it goes from 25 to 155. This is another one of those cases where we know it to the ones digit, so we have to be careful about how we write this with sig figs. So it goes up by 130, but we need to put a decimal point in here at the end to indicate that we know it to the ones digit, not just to the tens digit, as it would seem if we didn't put the decimal point there. So then we go through and we calculate that. I get 0.140 joules per gram degree Celsius. If you look on your table, you'll see that that is closest to mercury metal. Problem number 6 is asking us for heat. It says how much energy here, so Q equals mc delta T is the equation that we're looking at here. The substance we're talking about is ice. It's important to note that if you look at your table that ice and steam and liquid water all have different specific heats, so you need to find exactly which one you're talking about here. So we're talking about ice. M for ice, M for the ice it says here is 120.0 grams, and then C for ice, if you look it up on the table, is 2.060. And then if we look at the delta T, it went from negative 30.0 to 0.0. That's a change of 30. It looks like for the temperatures, we know those are to the tenths place, so I'm going to write 30.0 here for my change in temperature. Looking here, we have 4 sig figs and 4 sig figs and 3 sig figs, so our answer should have 3. You put that in your calculator and you get something close here to 7,420 joules. Number 7 says how much heat in joules is given out when 85 grams of lead cools from 200 degrees Celsius to 10 degrees Celsius. So this is asking for heat again, so we're looking for Q, which equals mc delta T. Plugging in the variables here, it's 85.0 grams. C here, it's talking about lead, so we have to look that up. It's 0.158 for the C of lead. Then for change in temperature here, it's cooling in this case. So the temperature is going down, so we're going to end up having a negative delta T. It's negative 190.0. You go ahead and you calculate all of that, and it gives you negative 2,550 joules. Now, the significance of the negative here when you calculate Q is it's negative if heat is given off. If heat is taken in, Q will be positive. In this case, it says heat was given off, so it's negative. However, the question said how much heat is given out. So in this case, we're actually just looking for the positive version of this number. So what we've got is 2,550 joules are given off. Question 8 here, it's asking for the mass. So we know that mass equals Q over C delta T. The joules given here is 41,840. C for water is 4.184. Delta T, it says it's going from 22 to 28.5. So that's 6.5 for the difference in temperature there. You run that through your calculator. There should be 2 sig figs on the answer here because we ended up with 6.5 here when we subtracted the temperatures. So just because the addition rule there with subtracting temperatures, we go to whatever decimal place it goes out to. It goes out to the tenths place. It just happened here that we got 2 sig figs when we subtracted those, so our answer can only have 2 sig figs. So if that's the case, it rounds to 1,500 grams. For the last problem here, again, it's looking for mass. It says, what's the mass of iron? So M equals Q over C delta T, which equals 425 over, and again you have to look up the C on your table, but C for iron is 0.444. Delta T in this case is going from 24.00 to 29.75. That's a difference of 5.75. You see that all the numbers in here have 3 significant figures, so our answer should have 3 sig figs as well. You get 166 grams. All right, if there are any of these that you are having problems with, I encourage you to look back through the key, listen to the problem again, see if you can figure it out. And if not, you can always come talk to me.